Uh, a very good afternoon to all of you, and a very good afternoon uh, uh, to our expert today, Miss Anita Sharma. I welcome all of you to celebrate the Mathematics Day with us today, which is 22nd December. We are not only celebrating the Mathematics Day today, but we are also celebrating it in a larger level, which is by celebrating an entire week for mathematics. So why Mathematics Day? National Mathematics Day is celebrated every year on 22nd December, which is today, in honor of Srinivasa Ramanujan. Ramanujan gave almost 3,500 formulas, mathematical formulas to the world that scientists still have not been able to prove completely. He is recognized for his mastery on continued fraction, hypergeometric series, Riemann series, functional equation of the zeta function, and elliptic integrals. We at Ashchand are not only celebrating Mathematics Day, but we have extended the same throughout the week. To do so, we have an impressive series of CPD sessions by experienced subject matter experts. Through our sessions for this entire week, we aspire to facilitate CPD sessions which our subject matter experts will be taking up with you guys. Our subject matter experts will share their best practices they have experienced over the years, so that what comes your way is wisdom which may be ready to use in your teaching context. Get ready for the tips and tricks to teach mathematics in an experiential way. A brief about today's session and our expert today. So the session will be on nurturing mathematical thinking amongst 21st century learners by Ms. Anita Sharma. A brief about Ms. Anita Sharma is that Ms. Anita Sharma is the principal of a reputed senior secondary school in Delhi, an educationist with an experience of more than 3 decades. She is widely known for her training programs. She has trained thousands of teachers in India and abroad in mathematics content, pedagogy, and assessment. She has long association with CBSE, NCERT, CIET, NIOS, SCERT, DST, etc. Her contribution is acknowledged by one and all, and she is conferred with the Life Achievement Award, Aryabhat Samman, by All India Ramanujan Mathematical Club. Some housekeeping rules to keep in mind during the session. It is requested from all the participants to keep themselves on mute during the session. You may use the chat box for all the Q&As. You are requested to fill the feedback forms received at the end of the session to receive certificates. And we would also request you to register yourselves for the remaining sessions that we have planned for the remaining week. If not done already, you may visit our website www.schandpublishing.com and redirect yourself towards our CPD corner, wherein you will find all the details about the upcoming events. The link to our website will be left in the chat box so that it becomes easier for you to redirect yourselves to our website. Thank you everyone for joining here today. And I would request Ms. Anita Sharma to take up the session from here. Thank you.
Thank you so much for your kind words and for inviting me to this platform to interact with the teachers. Let me just try to share my screen. Give me a minute. So I think something has happened with my PPT right now. Let me just bear with me. Okay, can you see the presentation?
Yes, ma'am. Yes.
Okay.
It is visible.
Yes, ma'am, we can see.
All right. So,
Just a request, ma'am, please put it on presentation mode. You'll find it in the right bottom corner.
okay. Just a minute. Let me try.
Right inside, ma'am, right inside of the screen.
Okay. Just a minute. Actually, because on the side screen, everybody's picture is appearing, so I'm not able to see that right-hand corner here. So shall I try to share it again?
You can press escape once.
Just a minute.
Yeah.
In the meanwhile, please tell everyone to be on mute.
You can also press Alt F5.
So the problem is that now when I have kept this, I stopped sharing, so I'm not able to get back now. Just
Ma'am, should I help you?
Anji, please बताएं.
हाँ जी, this is Priyamvada this side.
हाँ जी, प्रियंवदा जी, please.
हाँ जी, मैम आपने स्लाइड शो मोड में कर लिया उसको?
स्लाइड शो मोड में कर दिया.
हाँ मैम, अब आप अपने सिस्टम पे नीचे जो स्टार्ट की होता है with 4 squares कीबोर्ड पे.
What is happening on my system when I am doing it on the slideshow? I'm not able to see that Zoom screen.
Zoom, yes ma'am, I understand. That is what I'm saying. मैम आप नीचे अपने कीबोर्ड पे स्टार्ट बटन प्रेस कीजिए कीबोर्ड पे.
Keyboard
with those 4 squares. Ma'am, it should be next to your control and function key in the bottommost.
Okay, all right.
Just press it तो नीचे वो बार आ जाएगा.
Window.
हाँ, अब उसके अंदर आप you can now locate your Zoom.
Okay, yes, and now I can again share the screen.
Ma'am, can you once press?
But again it is
Alt
again
F5. Alt F5.
Alt F5.
हाँ जी.
Where is F5? F5 is on which side?
Ma'am, on the top
Alt,
row.
I got Alt plus.
On the top row. In continuation to escape, just skip escape and then probably the fifth.
Is it okay now? Is it okay?
Yes, ma'am. Yes,
Yes, ma'am.
Okay.
Thank you.
Okay.
Thank you.
So the topic today given to me was enhancing mathematical thinking and why it is important in the 21st century. So before I start, first of all, I pay my homage to Srinivas Ramanujam, whose 134th birth anniversary we are celebrating. And today is the day, 22nd December 1887, he was born, and we all know about his credentials. Himanish has already talked something about him. So I really love two examples from his childhood days. I would like to quote them here, and then we will move forward. So first example is that once he reached late to the school, and his teacher was aware of his mathematical abilities, and that teacher was timetable in charge. So and he never liked to make the timetable because it is a very, very clumsy exercise to arrange the timetable of the whole of the school teachers on all the 7 days, for all the 7 days. So he gave this as a punishment to Ramanujam, that since you have come late, so you will be making this timetable now. And within half an hour, he was able to prepare the timetable for the whole of the school, and the teacher was very, very happy. So this is one evidence of his mathematical abilities. And the second interesting example from his childhood days is that when he was used to sit in the class, always in his hands there was another mathematics book of the higher grades, because at the age of 7 itself he read that famous book on trigonometry by Carr, and he was used to enjoy the work of the very high level. So when he was in class 3 and the teacher started teaching the division, so the teacher was explaining the division to the students in this manner. He said, suppose you have 12 bananas and there are 12 kids in the classroom, so each will get one. Then he gave another example. Suppose you have 100 students in the classroom and there are 100 apples, then how much each will get? And our students were answering one. So Ramanujam found this very, very interesting. He thought that there is some special thing is going on in the school. And he stood up and he asked one question to the teacher. Sir, what will happen if there is nothing to be distributed and there is nobody to receive? Then how much will each get? So in a way, he actually wanted to ask that what will happen if 0 is divided by 0? So what will be the answer? Because the earlier results, when the teacher asked when the 12 bananas are distributed amongst 12 students, teacher interpreted that mathematically on the board as 12 divided by 12 is 1. 100 divided by 100 is 1. So the Ramanujam's question was, will 0 be divided by 0 and will it be equal to 1? So teacher, of course, outrightly rejected his question, and he said that what rubbish question you are asking in the class. And then Ramanujam went to the board and he wrote on the board, he tried to give explanation to his question. He wrote on the board that 2 into 0 is 0 and 3 into 0 is 0. 0 is equal to 0, and this means 2 into 0 is equal to 3 into 0. So if 0 by 0 is 1, then it is going to implicate that 2 is equal to 3. So is this possible? Do you think it will be, it could be possible? So if this simply means he tried to show to the teacher that if you say that 0 by 0 is 1, then the whole number system will shatter. So 0 by 0 cannot be equal to 1. You cannot say that if there is nothing to distribute and if it is not to be distributed amongst no one, then everybody is not going to get 1. So this kind of statement cannot be given. And we still know that whenever it comes to 0 by 0, we always say that this is an indeterminate quantity and we deal it with the help of the limits while doing the calculus. And with every expression for every function, we get different value. So this was his discovery at the age of, at a very small age when he was in just class 3. So we all know about the rest of his journey because all here are mathematics teachers. I am not going to talk much about it, but why I have started this example of 0 by 0, because our today's topic is enhancing mathematical thinking. And the kind of example I have taken here, actually the Ramanujan has demonstrated mathematical thinking. Now, why this word has become suddenly a very, very important word? Because when new educational policy, National Education Policy 2020 was declared, this particular word, enhancing mathematical thinking, has been given a very special emphasis in our policy. And when something comes into the policy, when something is part of the national education policy, that means it becomes the national objective. And our educational objectives, they are always driven by the national objectives. So let us try to understand more about this. So before I give you more examples, because our today's interaction will all be based on the examples and many examples. We all should be very clear, because when in the national education policy 2 words: creative potential, enhancing the creative potential of the child, and enhancing the mathematical thinkers is emphasized again and again. That means one thing is very clear: we should have a very, very clear understanding that in our classrooms, what kind of learners we want to produce. We want to produce the productive learners or the reproductive learners. Now, when I say productive learners, that means we want to produce the children who are the creative thinkers, who are thinkers, not only the thinkers, but the creative thinkers. And when I'm talking about the reproductive, so it is not, this is not used in biological sense, but actually I'm saying that we don't want to produce the learners in the class who are just prepared to reproduce what is learned in the class. So we want to get rid of the situation where the children are simply copying what is learned in the class and are reproducing in the answer sheets. So last year, this was a very popular message, and I got this number of times in a year, and on one day precisely I got this at least 100 times. And this all of you must have received this kind of message. This popular WhatsApp message was that this year is a very special year. Everyone has the same age, and this happens once in 1,000 years. Add your age to your birth year. For example, if your age is 63, birth year is 1957, its sum is 2020. So when it was a Corona year, 2020 year, everybody has added a mathematical specialty to this particular year. Now, I want all of you to reflect on this message, and you tell me, is this true only for the year 2020, or it is always going to happen? Whenever you will be adding your age to the current year, you are going to get, whenever you are going to add your age to the birth year, you are always going to get the current year. So if it was for the year 2020, age was 63, then you can assume that this year, this age must be 64, and even if the birth year is 1957, the same, the sum is going to be 2021. So actually, we need to teach our children to understand that whatever messages they are receiving, whatever information they are receiving, they shall not accept that information as it is. They shall always think about it and reflect about it, and try to verify also that whether the information given in a particular article or advertisement or piece of paper is correct or not. For national education policy, as I already shared with you, it lays particular emphasis on the development of the creative potential of each individual, and it is based on the principle that each individual must develop not only the cognitive capacities, but both the foundational capacities of literacy and numeracy, as well as the higher order cognitive capacities such as critical thinking, mathematical thinking, and problem solving. So this is also going to enhance their social, ethical, and emotional capabilities and dispositions. Indeed, this is always referred by Modi ji in his speeches, that with the quickly changing employment landscape and global ecosystem, it becomes increasingly important that children not only learn, but they also learn how to learn. So this mathematical thinking word here actually is referring to how to learn and not about what to learn. So our classroom environment shall inculcate this kind of attitude amongst the students, where they are more willing to learn about how to learn instead of just focusing on covering the syllabus or the content. So whenever we talk about, that means mathematical thinking, we want to allow to our children to have an understanding of the necessity of the required knowledge and skills, but also they shall be self-motivated learner. They must learn how to learn by oneself and also attain the abilities required for independent learning. I think some slides are disturbed. So I'm showing you another example. This is another WhatsApp message, and this I received from a school principal who is by chance is not a person of mathematics but the person of languages, and she was very happy to share this. She wrote me that I am sending you a very interesting message. You may never come across this kind of message, and this says, in mathematics, no number can be divided by all the numbers from 1 to 10. But this one number is very strange. All the mathematicians in the world shocked. And this number was discovered by the Indian mathematicians with their unwavering intelligence. So lots of exaggeration is here while quoting this. And if you will read the example throughout, you will find that there is nothing. See this number 2520, and it is one of the so many numbers which is divisible by every number from 1 to 10, whether even or odd. And then the calculations were given that it is divisible by 1, it is divisible by 2, it is divisible by 3, 4, 6, 5, 6, 7, 8, 9, 10, and so on. So how many of you agree with me here, who are all those who are present here, that this is the only number which could be divisible by from 1 to 10? Is there would anyone like to reflect on this? Is this the only number? So it is very simple that whenever you want to find out any number which is divisible by all the numbers, multiply all of them and you get the product and see that what number you are getting. And if you want to get more numbers of that kind, then multiply them again and again with various other numbers, and it is possible to get infinite numbers. So that means if such kind of examples come in front of you, take them to your class and give them a food for thought. You can ask your questions, you can curate the questions in many ways. Here, the first question could be, can you find a number which is divisible by all numbers from 1 to 100? I have extended the domain. That number was talking only about the numbers from 1 to 10. Now, I am saying that even if it is 1 to 100, even if it is more, the students, they shall be able to find out the number which is divisible by all of them. And when they will be dividing, they will be trying to find out all the numbers which are divisible by all the numbers from 1 to 100. Then, of course, between 1 to 100, there must be several numbers which are multiple of each other, or which have which have various factors which are there within the range of 1 to 100. So our next question could be, can you find the smallest number which is divisible by all numbers from 1 to 100? So for first question, if the simple answer may be 1 into 2 into 3 up to 100, then for the second question, the child need to now rethink that how to remove the duplicate numbers, the numbers which are going to give them the few greater numbers, which are the product of the several small numbers. So how to avoid that duplicacy? And for such questions, I will suggest that don't give them algorithm. Let them try to find out the answers themselves. Let them use the method of trial and error and reach to a conclusion. If they are able to find out some algorithm, then that's fine. Even if they are not able to find some algorithm or some formula, don't give them everything. Let them try again and again and let them reach to some conclusion, whether they can apply their knowledge or their methods, their observations to some other numbers or not. So we shall always, if we really want to inculcate mathematical thinking, if we really want our children to learn how to learn, we shall give them some space, we shall give them some opportunity to explore more and more. And you can always give this kind of opportunity where in those problems, when you are not much concerned about covering of the syllabus or you are not rushing. So you have in mathematics classroom and even otherwise, there is plenty of scope where this kind of opportunity can be given to the students. I am again giving you a very familiar problem. And this is a very, very simple problem. How many squares are there in the following figure? Now, when you ask this question in the classroom, you may get different answers. Some students may tell you there is only one square because they may be looking at the bigger picture. Some students may count all the 25 squares and may give you the answer as 25. Some students may add 25 plus 1 and they may give you the answer 26. So you may get various kind of answers, various possibilities are there. So whenever you come across such situations, don't tell them that you are right or wrong. Just tell them to think about it more. So help them to observe and also check the language which you have used. Now in this question, because the question is how many squares are there in the following figure, so everybody will give the answer as per the observation. Now there may be certain students in the classroom who may observe that the squares of different sizes are possible here. They may be able to identify that the square of the size 4 by 4 is also possible. Square of the size 3 by 3 is also possible. So that means if you really want to trigger their thinking after getting their responses, you can readjust the language of the question. You can change the language of the question as how many squares of different sizes are there in the following figure. So if you will just modify the language, the child will be able to understand that there is something more hidden in this picture, which they are not able to see right now. But if they take care of this particular word, different sizes, they may be able to explore more about this picture. So it is, what happens that sometimes there is gap in our thinking as a teacher and our students thinking, and this gap may be due to the communication also or due to the language which we have used. So we shall always be very, very careful that what language we are using and how precise we can make the language of the question if we really want to get a particular type of response. So this question, one thing is that here the language can be modified. How many squares of different sizes are there in the following figure? Now, when they start giving this answer, you can start consolidating the answer on the board like this. Number one, the squares with the squares of unit 1. So squares of, if each square which is shown here is considered as the square of the unit 1, then there are 25 possibilities. Then squares of the unit 2. Now here square of unit 2 means a square of order 2 by 2. Actually, yes, I think instead of square of unit 2, we could have write here the square of the dimension 2 by 2. So if they start counting the squares of the dimension 2 by 2, then they will be able to count many squares and they can reach to the conclusion that this is going to be 16. Then if the squares with the order 3 by 3 is to be counted, then that is going to be 9. The students, they can start finding these squares, and then squares of the order 4 by 4, and then square of the order 5 by 5, and so on. And then the total counting can be done as 55. Now, after this, what should be our next approach? How we can modify their thinking by asking different type of questions. If once the child has understood this, now you can change the order of the square. Instead of taking a 5 by 5 order square, you can now take a square of order, say 6 by 6, and let them count again. And once they are able to reach to the right kind of counting, this the same way, if they are able to reach to the right answer, now you can change your question, and the question may be that without even drawing this, without writing this detail, can you find out the total number of squares of different orders in a given square of order, whatever, 5 by 5 or 6 by 6? So without even counting, can you find that? And here will come the role of the mathematical language, the mathematical representation. Because in mathematics, mathematics has its own language. So the way we are representing certain things, that changes the meaning for the students. So if instead of writing like this, if I write down this as that number of squares, if I try to rewrite this whole thing as the number of squares of different sizes in this picture is 5 square plus 4 square plus 3 square plus 2 square plus 1. And again, for the square of the size of order 6 by 6, if I rewrite this whole thing in the mathematical representation as 6 square plus 5 square plus 4 square plus 3 square plus 2 square plus 1 square, then after writing this for 3-4 different type of squares, the child will be able to reach to an algorithm that without even counting, if this kind of picture is given, if any kind of square of order n by n is given, then the sum of the squares of all natural numbers from 1 to n is going to make the total number of squares in that figure. So what I am trying to say is that if we keep on asking the questions in the different language, in different manner, and are triggering their thinking, we will be able to help them to observe the patterns hidden inside and to make the generalized conclusions. Next example, before I take that, this is a very famous mathematician from Japan, Shigeo Katagiri, and you will be amazed to know that in 1945 in Japan, this mathematical thinking had become the part of their education policy, and it was written in the education policy that the objective of education given in the school is to enhance the mathematical thinking. And the quote which I have given, which I have written here, it is not from a very old book, it is from a very recent book by Shigeo Katagiri. And he wrote this, that he wrote in his book that till date we are not able to achieve this objective in the classroom. The reason is that the teachers are not clear about this, that how the mathematical thinking can be enhanced, or they themselves do not have that kind of ability that where they can take the decisions independently. So he tried to define mathematical thinking as the ability to think and ability to take decisions independently. And his book is about enhancing the mathematical thinking only. There is another very famous mathematician of this century. He is from US, Keith Devlin. You can find his talks on the YouTube. There are very famous TED Talks by him. And he also gave this very elaborated statement about mathematical thinking, that it is not same as doing mathematics. At least not in the way it is typically presented in our school system. School math typically focuses on how to solve the highly stereotyped problems, while the professional mathematicians, they think in a different manner. They attack on the real problems, the problems which could be arising from everyday world or from the society, or from the various branches within mathematics itself. But the key to success in school math is to learn to solve the problems out of box. And then he says that it is whole way of looking at the problem and not consolidated them as just a part of calculations. So every aspect is to be taken into care, whether it is the numerical part or the structural part or the logical part or the analytical part of the problem. So it involves adopting the identity of a mathematical thinking. So Keith Devlin also talks about various aspects of mathematical thinking, and he says that if we really want to nurture our children with this kind of aptitude, then we shall try to teach them that how to look at the problem holistically and how to look at each structure of the problem. So, of course, the question which immediately arises in our mind is that is teaching mathematics same as teaching mathematical thinking? I will say that if we are just focusing on teaching of mathematics, and that is the textbook of the mathematics, we might be able to say one day that we have enhanced the scholastic ability, but it is not actually the scholastic ability, but the academic performance of the child. But if you really want to enhance the mathematical thinking, then that means you are actually trying to enhance the decision-making ability of the child. You are making the child self-directed, self-motivated learner, and you are helping the child to be acting independently. So in order to be able to solve the problems independently, and the child needs to have more than knowledge and skill. In our examination system also, we have started talking about the higher order thinking skills. We are talking about the competency based teaching and learning, but what does all this mean if we are not able to translate them into those actions which are actually going to produce the high quality mathematical thinkers? So as a mathematics teacher, you can say that if because here all the mathematics teachers are there, so they would like to know that as per mathematical methods, what kind of mathematical thinking can be nurtured in the classroom. So I tried to identify various kind of thinking from the various sources, and came across 11 type of thinkings. So this is first kind of thinking is inductive thinking. Second is analogical thinking. Third is deductive thinking. Fourth is integrative thinking. Fifth is developmental thinking, then abstract thinking, thinking which simplifies, thinking which generalize, thinking which specialize, thinking which symbolize, and thinking that express with numbers, quantifies, and figures. Now, here are certain kind of thinking which you are already familiar with. Some names may look new to you, but some are very, very familiar. For example, if I talk about the inductive thinking and the deductive thinking, normally you know that in the classrooms we give the algorithms, and then we simply want our children to apply those algorithms in solving certain problems, and that is a kind of deductive approach in solving the problem and also in their thinking, because that kind of approach arises in their thinking also. You know, the way we teach certain problems, for example, in our country, when we are dealing with the linear equations and the quadratic equations, so we teach them algorithm how to solve the linear equation and how to solve the quadratic equation. And for that matter, we teach them whenever there is any word problem, we teach them that convert this problem in the form of an algebraic equation and then solve it. While if you look at the Singapore curriculum or the Chinese curriculum, then they don't allow this kind of conversions. We always motivate the children to convert the word statement into the mathematical expressions, but there they encourage them to use the unitary methods or or to make certain calculations based on the pictures. So they actually not motivate them much to convert them into the algebraic form. And the reason is they feel that if the child is converting the expression into the algebraic form and is using only algorithm, that means the set formula or the method, then the child is somewhere losing out on the logical abilities. So most of the time we are using that deductive thinking here. Inductive thinking, if I talk about right now, I gave you one example of that square problem, that once the child has been given the exposure to such problem, we shall try to see can he apply the same kind of pattern observation or his observations or his conclusions to the picture with the more number of squares. So if this can be extended and the child then further can reach to the generalization, then that kind of thinking is inductive thinking. Then is analogical thinking. Again, I gave you the example where I said that if I ask you to find out a number which is divisible by all the numbers between 1 to 100, you must have observed that in the second statement, the question was same. I wanted to have a number which is divisible by all the numbers from 1 to 100. But then I modified the statement and said, find out the smallest number. So the situation is same. The condition is added that now I want a number, but this number shall be the least number or the smallest number. So analogical thinking is that if you can apply, if you can solve the problem by having different set of conditions, or you can apply the problem to the different situation. So both the possibilities are there, that in the same problem, the condition is changed, or the same problem in context of some other kind of situation. So that is the kind of analogical thinking. Then is integrative thinking, and integrative thinking comes into the picture, especially whenever we are talking about the mathematics problem. When you try to connect the dots, when the child tries to find out the hidden information, and using the hidden information and given information tries to solve the problem. So many such problems we do address in the classroom, but we need to understand that how we can, by improving our questioning strategy, how we can help the children to work on those problems more eloquently. Similarly is developmental thinking. Here again, the stepwise approach is to be adopted to solve a very complicated problem. That means the problem shall be fragmented into the small sub problems, and then the child can start solving the small parts, and then in the end can join all the solutions together to reach to the final conclusion. Abstract thinking, I will not be, although it is written very clearly that it talks about the concretization and the idealization, and thinking in the different conditions. Thinking that simplifies, generalize, specialize, symbolizes. We all use all these kind of thinkings in handling the mathematical problems and in teaching. So I'm now moving further, and we will see that what more kind of problems we can address in the classroom and how we can enhance the mathematical thinking in the mathematics classroom. But before that, I would like to clarify one thing, that mathematical thinking is not limited to the subject mathematics. If we talk about the algorithmic thinking or the logical thinking or the rest of the thinkings, we may say that they can be developed in the mathematics classroom in a better manner, but mathematical thinking is actually applicable in every discipline. In every subject, this kind of thinking can be enhanced. Few days back, I was just asking somebody that when you say that you are going to buy a shirt whose size is 24 or a shirt whose size is 26, what does it mean? Now, this is a very simple statement. We all use this statement in our daily life. We all do purchasing. Whenever we go to the market, we say that we want this particular shirt or the trouser in the XL size or the double XL size or S or L. So what does all this mean? If we have not learned the interpretation of these phrases, which are very commonly used, and we don't know their mathematical significance, so that means somewhere we are not thinking scientifically and mathematically. So we need to teach at every step that whatever statement we are passing, whatever we are speaking, we should be very careful and we must know the meaning of what we are saying. I have already given this example. For inductive thinking, there is another interesting example given, although the square example we discussed, but this is another example where a child is asked to fold a single piece of paper perfectly in half from left to right. And then he has asked to fold it further and then fold further and then further. And the question is how many creases will be there after the 10th fold. So you can use in the classroom this kind of exercise to not only to create interest in the subject, but also to engage all types of students in your class. You know that the children with the different learning styles are there in the class. Those who are the mechanical learners, or we call them the kinesthetic styles, they want to do something with their hand. So for them, this kind of activity can be used. So let them try by folding the rectangle continuously, and then they may count it, and then they can use it with again different paper with different number of folds, and gradually they may reach to the conclusion. Those who are the analytical, those who have more of the analytical abilities, or their learning styles are different, probably they may reach to the solutions just by thinking logically. But for the kinesthetic learners, this kind of activity is going to really help them. I want to share one very interesting example with all of you, that how the mathematical thinking can be enhanced by every teacher. One day, a very senior teacher went to the primary class, and there he asked that what are you learning in your EVS class, environmental sciences class. So it was a class 3 EVS period, and the regular teacher was not present. So some senior teacher took the arrangement period, as normally happened. So students said that we are learning about wheel. So the teacher immediately thought, and he asked, Acha, okay, tell me how many wheels are there in the car? And a student responded that there are 4 wheels. He said, yes, fine. Think more. So another one said, no, sir, it is there are 5 wheels, because the steering wheel is also a wheel. So he said, that's fine, but why you are considering this as a wheel? So the child said that because the wheel is circular in shape. Okay. So many of the other children, they gather this idea that wheel is circular in shape. So they started thinking more. They said, oh, no. In my car, there are 7 wheels, because that meter which is there to tell the speed is also circular in shape. So somebody said that he counted some other circles in the car, and they kept on changing according to their observation. So the teacher never said anybody that you are right or wrong. He just kept on saying that think more, think more, think more, and they came with a different kind of solutions, and they were able to observe, they were able to recall, they were able to visualize. So see how many skills were improving. So it is not always important to get the right answer. More important is that when you are dealing with the children, that how you are encouraging them to think more and to visualize and to draw inferences. Then teacher changed the question. He said, Acha, okay, what will happen if the wheels are not circular? Suppose if we change the shape of wheel from the circle to the square, then is it possible? So a class 3 child who does not have any knowledge of the physics concept, who does not know about the friction, he was just trying to visualize, and the answer was, sir, I don't know whether this kind of car is possible or not, but I can vouch for one thing, and that is that if the wheels are square in shape, car will at least have 4 jerks while before completing one round. तो 4 बार jerk लगेगा कार को. उस बच्चे ने इतना make out कर लिया because he was able to see that there are 4 corners, and due to those corners the journey will not be smooth. So now this kind of thinking, when enhanced in the classroom, when the child start thinking about this kind of situation, then they may be able to apply them in the different field, and they may come up with some very creative work. So we shall always enable the children to ask more and more and to answer more and more. So to all the teachers, I always request that please don't ask the questions in the class which has only one answer. You should always have the scope of asking the questions which may have infinite number of possibilities. It should always be open-ended question. Don't put full stop, don't put a break on the thought process of any child. So give them the confidence that they may think differently, and they may think in the right direction also. So thinking, always happens at 2 levels. One is the conscious level and another is the unconscious level. So whenever we are thinking at the conscious level, it is always about our perceptions. We talk about the memorizing certain thing, visualizing certain thing, or some mental calculations, mental arithmetic can be done. But if we talk about the unconscious thinking, then that means we are actually referring to the thought of the unconscious cognitive processes. And these unconscious cognitive processes are very important because we try to understand about the world according to our unconscious cognitive process. So why I was focusing on open-ended questions, why I was talking about this example of a class 3 child with the wheels, because somewhere some unconscious process happens, and that lead one day to come out with the solutions of the different problems, or with the new discoveries. So we shall always be careful while talking to the children, that we are not touching them only at the conscious level, but at the unconscious level also we will be able to shape them. So thinking, this is again actually when the thinking is happening at the unconscious level, even at that time it says that the thought may be passive, but the process is always active. And in that active process with the positive thought, actually the result is to reach from the point A to the point B, that means from problem to the solution. It is that struggle, and the struggle can be overcome only by this active process in the passive thinking. So, okay, I'm not going with much theoretical things. Now I want to show you few more examples, that when I'm saying that we shall try to touch the children at the conscious and unconscious level both, and we can enhance the mathematical thinking at every place. It is not only that we are teaching them mathematics, and while doing the problem, only then we are able to enhance their mathematical thinking. We can do it at any stage with any subject with different approaches. If you just see the new education policy, especially in the class 6 to 8, it says that your pedagogies should be very different. The pedagogy should be leading to the experiential learning, and a proper integration with the outside world should be there. So it talks about the art integration, it talks about the sports integration, it talks about the integration with the sustainable development goals. It talks about the integration with the other subjects. So interdisciplinary approach is also there. So how all those integrations can be done, I am giving you a few examples here, that, and with the help of this example you can see that how the mathematical thinking can be enhanced. Now see, when you come across a piece of article or a piece of information, so what happens? First you try to understand the language of that article. So comprehension is the first step. Now, but it is not only the English language or the Hindi language, the language of the question, it is the mathematical comprehension also. Because what is expressed in that piece of information using various mathematical figures or mathematical representations, you also try to understand that, because that help you to actually elicit the information which is hidden, which is not given directly, but you can find out that information using this. So this is a SDG. This is a fact which is regarding the Sustainable Development Goal number 1, and the Sustainable Development Goal number 1 is no hunger and zero poverty. Now, what is the Sustainable Development Goal? It is actually seen that across the world, there are 17 problems which are common in every country. So a decision was taken by the United Nations that the whole world will be, and all the countries, they will be working towards finding the solution of these 17 problems. So these 17 problems are defined as the Sustainable Development Goals. That means in order to have a word which is sustainable and which is a developed word, we need to find the solution to these 17 problems. So in that, first problem is zero hunger and no poverty, because in most of the countries of the world, hunger is a problem. So you cannot say that you are in a developing country, so there is more poverty, and you are in a developed country, so there is no poverty. It is not like that. Poverty and hunger is a problem which is there in every country. So how to find a solution to that? But before finding the solutions, one must have all the facts in front of him. So this is a statement given by the World Bank in 2015, that 1 in 10 people were living on the US dollar 1.90 a day. US dollar 1.90 means almost 140 rupees. If we talk, I'm just giving a rough estimate, because almost I think 70 rupees is the price for $1 in terms of rupees. So 140 rupees. And then it says in 2015, 736 million people lived on less than $1.9 a day. So this is one question I wrote here, that if this statement is given that only 1 in 10 people are living on this cost, and then the number is given 736 million people lived on less than $1.9. What kind of information can we deduce from this statement? I wrote here one question, that can you guess the population of the world in 2015? This could be one question. But is there any other question which is possible? If anybody wants to reflect, please raise your hand and unmute yourself and speak. Anybody would like to reflect on this? This is one information. Anybody wants to speak?
Days means calendar, related to calendar information.
Calendar means, yes, if it is 365 days, then on one of the day. It is on a daily basis. So anyway, I'm moving to another. The first question which I gave here is, actually this question is referring to the analysis of the data. Now you read another fact. Another fact is, according to the World Bank in 2015, 1 in 10 people were living on this US dollar 1.90 a day. In 2015, 736 million people lived on less than $1.90 a day. And I am not able to see my screen. If somebody can read for me this, if you can read, that some billion fewer people are living in the extreme poverty. Some number was given here.
Ma'am,
Nearly
1990 is
1.1.
there.
Nearly 1.1 million fewer.
Nearly 1.1 billion fewer people
Yeah.
are living in
Yeah.
extreme poverty than in 1990.
Yeah.
So what kind of questions can be asked from this? Or and in other words, I will say that what kind of information you can ask the children to find from this fact. I have written one simple question, that what was population in 1990? Comparison of the population in the year 1990 to the population in 2015. Yes, that could be a very good question, right? Anything else is possible? So if you just try to contextualize,
ratio, ma'am. Ratio of both the
yes,
years.
when you are comparing, then this comparison can be done in different ways. It could be in the form of ratio, it could be in the form of percentage, it could be in the form of less than, greater than, it could be in the form of the difference between the population in the 2 years. So see, with this one word comparison, you can make at least 4 different type of problems here, isn't it? When you are saying that
Yes.
that you can compare the population in the 1990 with the population in 2015, then you can ask 4 different type of questions. What is the difference between the population? Which year the population was more? You can ask what is the ratio of the population in the 2 years? What is the percentage? What percentage of the population in 1990 was under poverty than in 2015? So So many kind of questions are possible. And this means a simple information which is given in the form of a word statement can be converted into a useful information, into a useful data, if we motivate our children to think mathematically. I'm showing you some more examples. Okay. Okay, I'm showing you another very interesting example, that how the decisions are made and how the knowledge of mathematics can help. Knowledge of mathematics with some more intelligence, which you may call as the common sense, which you were earlier calling this as common sense, or common sense जब word हम use करते हैं तो हम ये कह देते हैं कि it is not very common. So now I will say that instead of common sense, use the word mathematical sense. Okay. Now this is a problem which I found somewhere, that football match was going to happen, and the organizers, they were confused that how many tickets to be sold to view the match. This picture which you can see here, it is actually a picture of a very famous Australian stadium, and this stadium is one of the largest stadium of the world. Its name is MSG. So in MSG stadium, there was a football match, and there was an apprehension that almost 1 lakh spectators can be there to view the match. So the organizers were confused that how many number of tickets shall be sold, so that the crowd is manageable. Okay. Now, how they made the calculations that how many tickets to be released? I show you. They calculated the area of the ground. Which ground? Not the seats. Seats were large in number, but then they calculated this area of the green ground, okay, where the football is to be played. And this area, they found that this area is 17,720 square meter. Okay, so they thought, you know, nowadays this is mandatory for everybody to comply with whenever you plan any event which attracts large number of audience. Then you always have to see that there is complete arrangement to face any situation of emergency. So one need to comply with all the rules and regulations of the disaster management cells. So they thought that the ground area is 17,720 square meter. So suppose if any emergency occurs and everybody has to gather in the ground, in that green ground, then how many people the ground can contain? So they try to calculate that. So now, what was the expectation? That 1 lakh viewers could be there. This was the apprehension. And according to that apprehension, that means the area which will be required by per person will be 0.1772 square meter. Okay. Now, they calculated that a person needs space of dimension 0.40 to 0.443. And this calculation was done on the basis of the area which is occupied by a person while sitting on the stadium seat. Okay, so this was the space calculated by them, that a person occupies this much space. So after this, they thought that if the person has to stand in the ground, so it is necessary to see that what is the maximum area, maximum space the person will be occupying on the ground. So they took the measure of the shoe. So adult shoe has the length 35 centimeter. And then they also take into consideration the shoulder length. So shoulder length is roughly 60 centimeter. And this is, I'm sharing again this, that it is as per the Australian built, because this problem was regarding the Australia's football ground. So as per this, they tried to calculate that how much the person is going to occupy. That will be 0.35 into 0.60 meters square, and this is something 0.21 something. So earlier, for 1 lakh person, it was said that 0.1772 square meter per person, the space will be required. Now, one thing is very clear, that 1 lakh person cannot be accommodated, because if we see that as per their shoe length and shoulder length, they will be requiring at least 0.21 something square meter space. Now, when the person goes to watch the match, he must be carrying some bag also. Kabhi bag mein eatables, water bottle, kuch bhi ho sakta hai. So that means if the people are having the bags with them, they might be having the mobile also with them. And if there is some message or some call has to be made, then that means the child will be carrying the mobile. He should have the space where he can hold the mobile and listen to the phone carefully, or can call very comfortably. So, so a rough estimate was made that it is the space required will not be just this 0.21 square meter. At least 1 by 1 meter space is required, and this 1 meter by 1 meter space means that the space of, sorry, so this means how many tickets can that means only 17,720 people can be accommodated in that ground. So that means if everything has to be smooth, and if any emergency situation occurs, then not more than 17,720 square meter, no, 720% shall be allowed inside the stadium. So the organizers, they thought that they will be releasing only 20,000 tickets. Why? Because they have also considered that few percentage, in spite of buying the ticket, may not be able to turn up due to some emergency. So see, where the apprehension was that 1 lakh audience can be there, in order to have the smooth arrangement, the decision was made that not more than 20,000 tickets to be sold. So this is how it, now here not only the calculations, but also some futuristic aspect, some other compliances, other arrangements are also taken into consideration, as well as the comfort of the people who are there is also taken into consideration. So all factors are considered here. So this is one example. I have picked up this example from some place. It was not given in this form. I've converted this to accommodate everything here. And I just wanted to show you that when we are talking about the mathematical thinking, then what kind of questioning should be done to the students, and how we shall try to trigger their thinking. We shall always encourage them to think about the problem from different perspectives. And if we really want to achieve this aim, we want them to learn how to learn, then this itself shall be addressed in the classroom. And not only you do this, you should also encourage your other colleagues who are teaching other subjects to follow the same. So I think it is almost 5:14. If anybody want to ask any question, we can have some time for that. I've taken enough examples. So Priyamvada ji and Himanish, if you want the floor to open for the questions, then the questions are most welcome.
So the floor is open for questions. If anybody has any questions, you may please ask now. Otherwise, if you want to ask any questions later on, you can always drop in an email on the shared email ID, which I put in on chat. I'll be leaving the email ID in the chat box again. So I guess nobody has any questions. So we'll just wrap it up here.
Okay. So I hope that these examples, they must have given you some food for thought, and you would like to take them to the classrooms, and you will always be encouraging your students to think rigorously about any information which they are receiving from any source. They shall be put into the habit of verifying the information, to make certain calculation themselves. You can start with very simple things. Sometimes it may be like now the children, they are used to do lots of purchase through credit cards. There is a tradition of taking lots of loans from various sources. So how these loans, how these credit cards, they how much money actually they are costing, whatever is being claimed by these agencies, are they actually are the people actually getting that kind of benefits which are claimed? So you can always motivate the students to think from various perspective about the different kind of problems. And I hope that you will also be able to find out many such examples and will share with your colleagues. So thank you very much to everyone for being the part of this program, and
Thank you
for
so much, ma'am.
listening with patience.
Thank you so much, ma'am, for this wonderful session.
Thank you, ma'am.
I hope everyone attending the session is enlightened by the wisdom that you have imparted through this session. I'm sure that everybody took away something from the session, and which will help them teach mathematics more gracefully. I guess there are a few questions in the chat box. All right. So Neeraj was asking whether they can have the recording. Neeraj, the videos will be uploaded on our YouTube channel. Kinney Aroda, can PPTs be shared, please? Sorry, Kinney, PPTs are an intellectual property, right? So I guess they cannot be shared.
Sir, what is the YouTube channel name?
You can just search S1 Publishing on YouTube and you'll find it over there.
Thank you, sir. It was really interesting session.
Thank you so much. Thank you so much for attending the session.
Can you provide the link of that?
Of our YouTube channel.
Channel or particular this session?
The session will be uploaded in a day or two, so it can be circulated later on. So you'll receive the links through email.
Sir, please provide the link on our
Certificate
email.
for that?
Mr. Rajendra,
We will wait, sir.
you were saying something?